Hello, this is John Chernus again, and we are picking up where we left off. We just finished talking about UDP, User Datagram Protocol, which is a connectionless protocol. It operates at layer 3 of the four-layer TCP/IP model. Layer 3 is the transport layer, as you recall. So now we're going to look at the other main protocol that is used at the third layer, the transport layer. Again, these two protocols, you will never see them in the same frame, exact frame, at the same time. You'll either have one or the other. So we already looked at UDP, User Datagram Protocol. Now we're going to look at TCP, Transport Control Protocol. And I have opened, just from the last session, the same capture session I did early on in the lessons with the access to the San Diego State University website. And we've gone over ARP, we've gone over DNS. DNS is an application layer protocol. DNS was used to illustrate the UDP protocol in layer 3. DNS is in layer 4. Now we're going to look at TCP, which is again in layer 3, but this is what constitutes a connection-oriented protocol, transport control protocol. So if you're running a program like Wireshark and you're looking at packets, if you see the TCP protocol in the particular packet, you know it's a connection-oriented protocol. Again, down here in frame 8, if you see HTTP, we'll talk about that in a minute, that's also a connection-oriented protocol. So TCP and HTTP are both protocols that have to do with connections being established. In fact, TCP operates in layer 3, the transport layer. HTTP is an application layer protocol that operates in layer 4. Okay, so what I want to do is go over how do you know that you have a handshake. A handshake is the definition of establishing a connection. So whenever you hear the term handshake, TCP/IP handshake, that just means you're using a connection-oriented protocol. Pretty certain it's going to be TCP, and you have what's known as a three-step handshake. So I want to go over that handshake right now. So the question is, who starts the handshake? The answer is it depends. It's usually the host, the computer on the network, that initiates the connection with the other machine. So as you recall, in this same capture session we've been looking at, I simply captured the traffic when I typed http www.sdsu.edu. I'm connecting to the San Diego State University, so it seems logical that the TCP/IP handshake would come from me. Well, let's see if that's the case. Well, we've already gone over the first 4 frames. Let's start with frame number 5 here. Frame number 5, yes, that is initiating from me. As you know, that's my IP address, 192.168.1.107. The San Diego State University web server is 130.191.8.198. We learned that up here, as you recall, in frame number 4, where it shows the response from the DNS server, giving me that address so I could then establish a connection in frames 5, 6, and 7. So when you have 3 TCP frames that follow in sequence, and we'll see the sequence in a minute, you have a handshake and you have a connection. The thing that is a dead giveaway that you have a handshake, let's look at this a little more closely, is when you have a sequence number that starts with 0. Do you see that right there? That's in the 5th frame. When you see sequence number equals 0, that's the start of a handshake. And the way this sequence follows in the 3-step process, again, this is a frame coming from my computer to the San Diego State web server. It starts with sequence number equals 0, and then the next frame coming from San Diego State's web server to me will have an acknowledgement number of 1 and its own sequence number of 0. The acknowledgement number of 1 simply means the next frame that it expects to receive from me will have a sequence number of 1. So an acknowledgement is just talking back to the other host saying, I got your prior frame or packet, and the next number I expect, the next sequence number I expect from you is the value of that acknowledgement number. So what this means is the next frame, the 3rd frame in the handshake, should have a sequence number of 1, and it does, and that's what it has there. Okay, so basically this is what constitutes a handshake, these 3 exchanges between the client, my computer, and the server, the San Diego State web server. There's a lot of other things going on here that are pretty much beyond the scope of this project, like win, which actually means window size. We won't go into that. I can talk briefly about MSS. MSS simply means the maximum segment size that can be put into the packet in bytes. This is what's known as the payload in the frame, not the entire number of bytes of the packet or frame, because that contains a lot of overhead, as you know by now. Source and destination IP addresses, port numbers, physical addresses of network cards, lots of other information. That's all the overhead involved in getting the packet delivered to its destination. What that MSS is talking about is the actual payload. It equates basically to putting a letter in an envelope and mailing it. The overhead are things like the envelope itself, the return address, the stamp, the sender address, that kind of stuff. That's all overhead. The payload is the actual letter that you wrote that you stuck in the envelope, and that's what this MSS is referring to, the actual payload, the actual data that's being sent in the packet from the source to the destination. So in terms of networking, that would be like part of a text document that you're sending to somebody, or emailing to somebody, or a print job that you're printing to a network printer, or it could be a picture that you're downloading from a website. That whole picture is coming down in these small packets, and the payload is the piece of the picture that's in that particular packet. So I hope that makes sense. So that was a frame from me to the web server of San Diego State. And this one, San Diego State's web server is telling me that its maximum segment size that it can send in frames back to me is 1380. So it's a little bit smaller for some reason. So that's just a negotiation that goes on between the two machines establishing the connection. It's just an exchange, and there are a lot of other things in there, but I don't want to get into all that. It's just the handshake is basically an exchange of parameters between the two hosts. It's a negotiation of how they're going to be sending and receiving data from each other. Okay, so that is a quick summary of TCP. Now what I want to do is talk very quickly about identifying particular problems on the network. And this is a one that really warrants some attention. You may have heard in the news or read somewhere in a blog or a wiki or somewhere about what's known as denial of service, or a denial of service attack. And really what a denial of service attack is a variation of the TCP IP handshake process. So I want to go over that really quickly. Remember when I talked about UDP, that UDP didn't have much more in it except for port numbers that identified the source and target applications on both sides of the communication? Well, let's see how that is different with a TCP frame. So I'm going to simply open up this frame 5 and take a look at it. Actually, I don't need to do it here. I'll do it down here. So again, when you're looking at these frames, we need to focus, in this case, we're going to focus on the transport layer. The transport layer is always what contains the source and destination port numbers. And here, again, just like we saw with UDP, we see a source port number and a destination port number. This is a frame that's being sent from my computer to the San Diego State web server, and basically I'm indicating a source port number associated with my computer's application and services, 1265, and that has to do with DNS. And this basically, I shouldn't say DNS, that doesn't have anything to do with DNS. Basically, that's just the side of the communication related to my computer's communication for the browser with the web server. HTTP is a little bit better understood and known. That's port 80, and that has to do with the web server service running on the San Diego State website, whatever it happens to be, Internet Information Server, maybe some type of other web service like a Solaris-based web server or a Unix-based web server. Apache is a very popular, the #1 web server out there on the market. They all do the same thing, but basically this server has to be listening for port 80 traffic. That means a frame coming into the San Diego State web server. When it comes in, that frame is looked at, and if the number matches a service that's running on that server, that frame can be processed. So their server is running port 80 or listening for port 80 because it's a web server. That number is associated with web servers. That's why this frame will arrive and be processed by the San Diego State web server. So this is very similar to what we saw with UDP, but there's a lot more other information in here besides that. Here's the sequence number that I talked about. So this is the first frame. This is frame number 5. This is the first frame in the TCP handshake, and that's always signified by a sequence number of 0. So you can see that. So that is a little bit different than UDP because we have more information in here. The big change is the sequence number. We see that in here. When we go to the next frame here, we see there's a sequence number of 0. This is coming from the San Diego State web server back to me, to my computer. and it also has the acknowledgement number of 1, and basically, as you recall, that means it expects the next packet from my computer to have a sequence number of, remember, of 1. And if I go to the next frame, for me, that completes the handshake, I see my sequence number is 1. And that's what completes the handshake. All these other things like window size, maximum segment size, all that information, if you dig in here, you will find that information under the transport control protocol. So basically, having these 3 packets, to kind of sum it up, is what constitutes a handshake. Now what I want to talk about is, again, with this denial of service, a clear indicator that a denial of service attack is happening on a server is if somebody's running like a network engineer, such as maybe that's what you want to be if you're taking this class. If you're running some kind of program like this Wireshark program, and you see that you don't have 3 steps in the handshake, maybe you just have 1 step and then the second step, and then the third step doesn't show up, it isn't there, and then you see another connection or another handshake initiate. What I'm talking about is a denial of service attack, where you're not really setting up connections. What's happening is some host on the internet is attacking your server, and it's setting up what's known as half-open connections. It'll initiate the first packet and with whatever port number is associated with that packet, for example here, and then the other port number to identify the service or application on the server. And the way it tricks the server, if the server isn't adequately patched to deal with these kind of scenarios, is it will vary the port numbers slightly to make the server think it's a different type of communication. But what happens is the first packet gets delivered to the server, right here in frame 5. The second frame from the server back to me, or whoever is doing this denial of service, is sent back. And then the third frame from the machine trying to connect to the server, it never happens. You'll never see the third frame in the handshake. What will happen is that host will send another start of a handshake with the first packet, and it changes the port number slightly to confuse the server. So the server in the meantime is keeping all these connections established, waiting for that last third frame to finish the handshake, and it just kind of is sitting there hanging, waiting. Well, what happens is over time, as more and more of these connections add up, these half-open connections, frame 1 and frame 2, but no frame 3, the server actually gets overwhelmed. The resources, the RAM, the memory, the processor gets tied up managing all those half-open connections. It doesn't have the knowledge to drop those connections until it's adequately patched or knows how to deal with these types of issues. So what happens is the server comes to a halt. It can't accept any more connections because it gets overwhelmed with all these half-open connections that are just kind of keeping the machine's resources, the server's resources, tied up. And that's basically what a denial of service attack is. So to make a long story short, is if you only see the first 2 frames in the handshake, you don't see the third one, and then you see a new handshake start with a sequence number of 0. So if I see sequence number of 1 in the third frame, that's a good sign. That means the handshake's completing. If I see sequence number equals 0, that means I'm starting a new handshake, and if it's coming from the same host, that's a very much a dead giveaway that you have a denial of service attack going on. So that's something when you're troubleshooting network connections you should be aware of. It can definitely happen. Another variant of that is a distributed denial of service attack. It's basically very similar, but instead of one host attacking the web server in this case, it could be thousands of hosts all out there doing the same thing but from their own computer. And that'll bring the server down to a halt much quicker because you could have thousands of hosts making these half-open connections to that one server, and within a minute or 2 it could bring the whole server down. This has happened, and you may have read about this kind of stuff happening in the news. So that's why a handshake is very important. It establishes the parameters of connection, and also when you're troubleshooting the network and you get a call that a server is slow or unresponsive and other servers on your network are working properly, this is something you would want to check for. You want to check to see what's going into that server and see if you have these half-open connections going on. The server may be under a denial of service attack. Okay, I think we're going to stop now, and that wraps up our lesson on TCP.